Welcome back, everyone. This is Mini Coder with another episode of Basic Programming 101. We just finished up Inheritance in Classes Part 1, well, Part 2 if you include the PowerPoints, and this is Part 3. So what we're going to go over today, we have set up our Animal Abstract class, which is over here. We added a string and public name that allows you to get the value and set the value. Same thing with the speed. We have two public methods, one being virtual called make noise, which is optional to utilize within your inheritance. That's why there's open and closed brackets, because you need to have a body in here, because animal is going to implement its own, and the inheritors, the concrete classes, may or may not implement this make noise method. And the last one here is the abstract method. So an abstract method doesn't have a body because it is requiring every concrete class that inherits from from the abstract class. It requires them to implement their own version of this method. So animal will never be used, because every single time you, as the inheritor, as the concrete class, you are required to create that method. So you're overall, no matter who the inheritor is, they are going to override that method. Otherwise, you're going to get a red line, compile error, just like we did when we didn't have this method, right? If you remember correctly, when we didn't have it, it says, hey, you have an abstract class that you're inheriting from, and this method must be implemented, where we did not on the make noise. We can, however, do, and I believe we'll even get IntelliSense for this, public override. And you'll see right here, these are the common ones, which we haven't even gone over object yet. But if you notice, there's a make noise. Now, this make noise will override whatever the animal would have done, and we'll show that in a few minutes. And you can, if you want, call the animal method after you call this method. And you'll see in a lot of languages they do this for if you want to intercept what's going to eventually happen and do your own thing first. So when you say base, wonder what happens. Yeah, CLC, it highlight animal, because it knows that the base, the abstract class, is also, you'll hear it referenced to very often as the base class. Just like these dog and cat classes, you will often hear them being called the inheritor class, or more commonly the concrete class, because it is a concrete object. It is something that in most instances you can feel, you can touch, you can, or at least see. Like if you have a form abstract class, its form, you know, if you're used to like input boxes or date pickers, those will probably be concrete classes that inherit from the form abstract class, because those are tangible objects. You can see them, you can feel them. Animal is not itself, in and of itself, a tangible object. So hopefully everybody understands that. Please, if you don't, leave some comments, and I will try to either make another video that explains abstract and concrete classes a little more in depth, because I know that was not the easiest thing for me to follow at first, or I can just answer your question within the comments. So either way is fine with me. Just please don't hesitate, and I will get back to you as soon as possible. So now, what I would like to do here is we're going to set the speed of the dog. So, as you can see in an animal, there is no speed already currently set, right? There's a getter and a setter, but we're not actually doing anything yet. So just to give some information here, so let's do Well, here, let's start with explaining what this is. So, there's a left side and a right side of the equal sign. The left side is what object you are going to be creating. A name, a variable name is what they call it, because this is going to end up being a variable. Um, so the name you're going to call it equals new means I'm going to new it up, or I'm going to initialize a new instance of dog. And then as soon as you do dog open and close parentheses, obviously this is given the fact that there is no actual parameters you're passing. You can pass it in there. New dog is going to be set in memory. So there'll be a slot in memory that's going to have just enough space to consume all the properties and all the methods in the dog, and it'll take into account that there's strings and how big it can be, and integers and how big an integer can be, and all of that stuff. It'll take that into account when it's assigning it. It won't assign the full memory, but it'll assign an address that can be expanded and all that good stuff. And I don't want to go that deep into it. So just trust me that now that you say that, now if I hover over this, now we have type dog, and if I want to, I can do dog dot, and I get everything that's related to the dog. So we have a name, we have a speed, we have a method called setSpeed, we have a method called makeNoise. We're getting that from the dog itself, right? If you see name, we're actually getting that from animal, so you can see exactly where it's coming from. Whereas make noise, because we did an override, it's coming from dog. So let's do speed equals 0. Okay. And then, so we're setting speed, and then we do a console. Where we go? Console dot right line and dog speed is plus. Remember we talked about concatenation down below, so we're concatenating that string with dog.speed. And I think everybody probably knows what's going to happen here. The logical thing would be that it's going to look at the dog object, find the property speed, and console that, write it out to as a 0. And there you go. So it's set to 0. Okay. So now let's do this. So now we've got dog dot set speed. Okay. Now, as far as we know, it takes in a speed. So let's just give the dog a speed of 12, right? Why not? And if we remember, if you click on a method and hit F12, it'll take you right to it. So we haven't completed this yet, so this won't actually work right now. So we're setting speed. Now, if you remember correctly, so we're going to pass in the speed. Now, what we can do is there's a keyword called this, and what this does is it gets anything that has to do with dog, and by inheritance anything that has to do with animal. So this dot, and you'll see everything that has to do with dog or animal. So this dot speed is equal to speed. Okay? And if we were to hit F12 on this thing, you see it takes you to animal, and there's your speed. So hopefully I'm not going too fast here. I'm already at 9 minutes, so I'm kind of trying to go with the flow here. So in theory, what should happen is we should set the speed. We're passing in 12. It should go into dog, go into the speed of the animal, and set the speed to 12. And then by the time it gets to here, it should spit out 12. So let's see what happens if we run this. There you go, dog speed is 12. Now, to kind of capitalize on this, here, why don't we do this? We will do animal, right? And we already know we're going to have a few problems, so let's get rid of these, right, because they're redundant now. And we're going to want to implement the abstract class, which we're not going to do anything with right now. And let's do a public speed, set speed as well. Right, and int speed, and we set this dot speed equals speed. Okay. Oh, and I forgot to put void here, so it doesn't know what my return type is. There. Okay. So, just to prove out that there is no bleed over, let's create a cat. So we got cat, not cart, cat equals new, because we're going to new up, we're going to initialize a cat. Okay. And, whoops, oh, that's fine. I don't want to, I'd rather not do that. Okay. And cat dot set speed equals to 32. Okay. And then what we're going to do here is we're going to just add a new line. We'll call it cat speed and cat speed. Okay. So, in theory, what should end up happening is we have console write line dog speed equals speed, which should end up being 12. We created a new cat, set the speed to 12. So what should happen here is cat speed is cat.speed, which should end up being 12. So let's run this and see what happens. And there you go. Cat speed is 32, dog speed is 12. So although you're inheriting, each one has its own version or own piece of animal. Okay? And that name and that speed are personal to cat and personal to dog. So you can see where there's some value in having this one base class. I mean, what if all of a sudden, for whatever reason, you wanted to have, I don't know, you wanted to add a new method, a new property called, I'm just going to use my thing, prop, and prop and tab will give you your thing here. So you wanted to add a new property integer called age. Okay. Now, if I, for whatever reason, wanted to, this dot, and there you go, age is there. So you can tack on, you can remove from animal. I wouldn't really suggest it because now you have things reliant on it, at least after the structure phase. But the ability to add, remove properties and methods within an abstract class and have it be inherited, and especially where something's going to be redundant. Like one thing, once you get into data structures, that happens a lot is if you want an audit trail, you need a date time, and you'll need like create a date, right? Come on, you'll need created, or actually our DBA would much prefer date created. Okay, right? Because it wasn't a created date; it was a date that it was created. So anyway, just nitpicking this. So you might want that every time a cat gets created, every time a dog gets created, every time a bird gets created. Well, if you have to update all those properties, and then let's say, oh, you know what? I don't really care about the date time. I just care about the date. Is there not a date here? I think that was a bad example. Yeah, there's no date here. So let's say instead of a date time, you want a time span or something, right? Boom. Now you can use it. It will obviously break other code that might be using it, but hey, you can update it here, and then you'll have your compile errors and you fix it. So there's a lot of value in using base classes. Also, one thing, if you want flexibility, and I don't really recommend doing this, but you can inherit without being an abstract class. And I'm not saying that I don't believe in inheritance without being abstract. There are base class situations where you may not want that. But in a situation like this, where you have the highest level method or object, you really want to try to use abstract if you can. It's almost like if anybody here that's listening is a JavaScript fan, doing use strict versus not using strict. You're by using abstract, you're locking down what people can do with it, especially since you can't create a new one. And what I meant by that is these new ones, like I newed up a cat, I could do animal here, and that's great. And then an equals, if I do new animal, it's going to bark at me and say, hey, sorry buddy, you can't create a new memory instance of an abstract class or an interface. My bad. So that way somebody can't come from underneath you, add a new property, or set something within that because you might have something here that's a constant, let's say, right? Whoops, sorry about that, guys. My other video just finished. So you may very well need something like a constant. So a constant is something that never changes throughout your code. So you might have public constant string, I don't know, stuff. I don't have a good example right now, but test 1, 2, 3, right? If you took away this abstract class, somebody could easily come in, well, that's a bad example because a constant you can't change. Without the constant, how's that? Without the constant, somebody could easily come in and change that right underneath you without your knowledge because it's public. So I can easily come in here now with that changed and do animal dot, or I'm sorry, animal equals new animal, and then do a dot, and there's your stuff, right? And I empty it out. Now, if cat and dog relied on that for whatever reason, now some other developer just emptied out stuff, and dog and cat may be under the assumption that stuff is never empty, and then you've got a broken program. Even if they're accounting for it, they're expecting it not to be that way because it's part of the abstract class. So that's an example of where you would not, why you would want the abstract class. So it looks like we're about a little over 18 minutes. So what's this? Oh, because I didn't have abstract here. Let's actually get rid of all that so we can keep going here. So let's go over get name. So get name right now is throwing an exception, which we haven't gotten into. So instead of, what we're going to do is get name. Now forget about the name property for right now. What I'm trying to show again is that when you override a method in dog and cat, there is no bleeding over. So you're requiring every dog to have some sort of name and have it set, be able to retrieve it. In fact, probably a good example of this, doing this, would be don't allow it to be set, like that. Okay. Yeah. Don't allow it to be set, just get, right? So what's cool about this is name is equal to doggy, right? Really? Okay, I thought you could do that, so scratch that. Alright, so get set. So what we're going to do here, the typical, I was going to go a little further into it, but the typical I want to return something, string. See, now here's where while you're developing, you can easily change all this very quickly. So there you go. So we're going to return doggy on the override get name, and then cat also has the same thing. I need to change it to string so it has the same. This is called the signature to most people, or message in Objective-C. So what we're going to do here is we will return meow cat, and that should get you what you're looking for. So if we go here and let's do 2 of these here. Dog says dot get name, okay? And it will concatenate because the return value is string, so the compiler already knows that this whole thing will jibe because it's a string. Just as an FYI, we could easily have set it equal to a parameter, but in this case, just for simplicity, I'm not going to do that. So, without further ado, dog says doggy, cat says meow cat. Let's see if it works. And there we go. Dog says doggy, cat says meow cat. Alright, so in the next episode, I think we're going to wrap up inheritance. I think I've kind of beat that down for now. And let me look at my thing here. I think what we will probably work on next is we'll define properties of class a little bit and the differences between a get and a set. And then we can take it a little further, and if I get any responses back that inheritance or abstract classes need to be defined a little better, I will do that. But since I've already done 2 20-minute sessions, I don't want to go overkill if everybody's understanding it. So again, don't hesitate to let me know. Otherwise, I'm going to assume everybody's good, and I will move on. Alright, thank you very much. Have a great day.